let's take a look at percent yield and what it means. Percent yields is you take your actual yield found during an experiment or industrial process, and you divide it by your theoretical yield, and that you find using stoichiometry. You can times it by 100 to make it your standard percentage form. So basically what this is saying is you do some stoichiometry on a chemical reaction, and the stoichiometry says you should get 100 grams of this product. Then you go and you do the chemical reaction, but you only get 60 grams of the product. Well, your percent yield in that case is 60%. You got 60% of what you should have. Analytical chemists try to get actual yields as close to possible as the theoretical yield to maximize production. Calculating percent yield is a way of seeing how accurate a reaction has been. So your theoretical yield is a prediction of how much product should form based on the stoichiometry of the reaction. The actual yield is the amount of product collected during an experiment or industrial process. It's usually less than the theoretical yield. So here's an example. Our actual yield is 239 grams. Our theoretical yield is 410 grams. So our percent yield is 239 divided by 410. And you can hear my chair squeaking as I go to get my calculator. And you just do that question on your calculator. It shouldn't be too hard. You should already have the answer by now. Well, I'm here searching for mine. $239 divided by 410 is equal to 0.5829. Well, this guy so far has 3 sig figs. This guy looks like it only has 2, so it should be 0.58 or 58%. There we go. There's our percent yield. Most of the time, you have to figure out the theoretical yield first. That's what we've been doing with stoichiometry, and then calculate the percent yield. Right, so an ideal or theoretical yield of a chemical reaction would be 100%. That value is rarely reached. According to Vogel's textbook of practical organic chemistry, yields around 100% are called quantitative. Yields above about 90% are called excellent. Yields above about 80% very good. Yields above about 70% good. Yields below 50% are fair. Yields below 40% are poor. Yields may appear to be above 100% when products are impure. So you're doing a chemical reaction and you're asked to get calcium hydroxide out of the chemical reaction. But your product has calcium hydroxide and some other thing in it that makes its mass over what you predicted should have happened. So you've got to adjust for that. All right, so let's take a look at the example questions. All right, so chlorobenzene, C6H5Cl, is used in the production of important chemicals such as aspirin, dyes, and disinfectant. Industrial is how chlorobenzene is produced. C6H6 plus Cl2 gives us C6H5Cl plus HCl. When 36.8 grams of C6H6 react with excess chlorine, that means this is our limiting reagent. We're going to have lots of this stuff, so we'll get left over. The actual yield is that. What is the percent yield? So how do we solve this? Well, we're going to do stoichiometry. We know this guy, 36.8 grams. Well, first we have a balanced chemical equation. First. Then we identify what we know. We know that much. We're trying to figure out this guy. So let's build our pathway. We start off with our mass of C6H6. We go to our moles of C6H6. Then we're going to go through our molar ratio to get our moles of C6H5Cl. Then we're going to get our mass of C6H5Cl. So we've got 36.8 grams. That's 3 sig figs. So by the time we get to our bottom, we will have 3 significant figures. So we've got to do our molar masses. 12 point, nope, I need to go to a new line. 12.011 times 6 plus H 1.008 times 6. So how many moles are there going to be in 36.8 grams if 1 mole has 78.114 grams? So we get 0.4711. I keep my whole number in my calculator. We need to keep 4 sig figs in there. So now we use our molar ratio, and our chemical equation's balanced. It's a 1-to-1 molar ratio, so we can just write this number down here. So we're going to get that many moles, 0.4711. Then we have to do our molar ratio of, so we have to do our molar mass of C6, 12.011 times 6 plus 1.008 times 5 plus chlorine 35.453. So how many grams are there in 0.4711 moles if we've got 112.559 grams in 1 mole? So we multiply those two numbers together, we get 53.0. To 3 significant figures. We should keep a couple more because we're going to use this number later on in the question. So this is our theoretical yield right here. That's theoretical. So now we can go over here and figure out our percent yield. My green pen is almost done. So we do our actual divided by our theoretical. So we do our actual is 38.8 grams divided by 53.027 grams. And our final answer should have 3 significant figures because this guy has 3 significant figures. This guy should have 3 significant figures. We just keep more because we're in the middle of a question. 38.8 divided by our 53 number, 73.2%. There you go. That's not bad. We got, this number is 73.2% of our theoretical amount. All right, so let's take a look at another example. You should be good at stoichiometry by now. Impure nickel can be purified by first reacting it with carbon monoxide. Nickel solid plus 4 carbon monoxides gives us nickel SCO4. I don't know what to call that. Calculate the theoretical yield of nickel carbonyl in this reaction if 23.5 grams of nickel reacts with excess carbon monoxide. Calculate the percent yield if 61.0 grams is actually collected. All right, so we start off, we have a balanced chemical reaction. We know we have 23.5 grams of this. We know that this is an excess, so we've got lots of that. We're asked to find out how much of that do we get. All right, so let's build a map. We're going from mass of nickel, which is 23.5 grams, to our moles of nickel, using our molar mass, then to our moles of nickel CO4, using our molar ratio. And our molar ratio, it's nice, it's a 1-to-1 molar ratio. It just means we copy down the numbers. Then we figured our mass of nickel CO4, using our molar mass there. All right, so how many moles would there be in 23.5 grams if 1 mole has, where's nickel? 58.693 grams. 58.693 grams. So I do 23.5 divided by 58.693, 0.4004. I need to keep at least one more, but I'm keeping the whole number in my calculator. So then we just write it down here since it's a 1-to-1 molar ratio. Now we figure out, do our last one. How many grams will there be in 0.4004 moles if, I've got to do nickel CO4. Nickel is what? 58.693 plus to that 4 carbons, that's 12.011 times 4, plus to that 1.008 times 4, and I get a total of 110.769 grams in 1 mole. So I take that number, times it by that. I get 44.35 grams, 44.4 grams. That's my theoretical to the correct number of sig figs. Right, now we're going to go do our percent yield. Actual divided by theoretical. Actual was 23.5 grams. We divide that by 44.35 grams. Right, keep an extra sig fig along. Although this should have 3, so our final answer will have 3. So 23.5 divided by that number. It's going to round to 53.0%. 3 significant figures. There you go. That's how you do this. The last example is a little more complicated, but I hope you see how the stoichiometry goes. I hope this is easy for you by now, and you understand what to do. And then this is just a little thing added on at the end. Last one, a bit more of a challenge. In an industrial process, aluminum reacts with excess copper to sulfate. If 1.85 grams of aluminum reacts and the percent yield is 56.6%, what mass of copper is actually produced in the lab? So we're going to write the balanced equation. We're going to calculate the theoretical yield of copper that should have been produced. And then we're going to calculate the actual yield using our answer from that. Okay, so I'm going to say over here, I'm just going to write our percent yield equation. Percent yield is equal to actual divided by our theoretical. Right, this comes from our stoichiometry calculation. This comes from our actual amount. We know our percent yield here. Our percent yield here is 0.566. It's equal to our actual, which we don't know. That's what we're trying to find out. And our theoretical we can get by doing stoichiometry. Okay, so let's start. Aluminum. So we got aluminum plus copper 2 sulfate. And sulfate, it's CuSO4. And we are going to get copper by itself. And aluminum sulfate. And aluminum sulfate is going to be Al, because Al is a 3+ charge, Al2SO4 3. Aluminum sulfate. That's ionically balanced. Now let's balance this out. All right, aluminums. We need 2 here. I'm going to use a different color so it's easy to see. 2 aluminums to balance that. We need 3 of these guys to balance that, and then we're going to need 3 of these guys. All right, so here we go. What do we know from our chemical reaction? Well, we know 1.85 grams of this, and we're trying to figure out how many grams of this. We do have excess of this, so we're going to use up all of that 1.85 grams. So we're simply going to go from our mass of aluminum to our moles of aluminum. Our mass of aluminum is 1.85 grams. Then we're going to go from our moles of aluminum to our moles of copper. Then we're going to go, that's going to be our molar ratio. Our molar ratio is 2 to 3. Then we're going to go to our mass of copper. Sorry. This is going to get our theoretical amount of copper, which can then go into this equation, and then we can figure out the actual amount. All right, so first thing, how many moles are in 1.85 grams? If 1 mole has aluminum, where's aluminum? 26.982 grams. 1.85 times 1 divided by 26.98, 1.85 divided by 26.982, 0.068564 moles. That's our first step. I keep this number in my calculator for the next. So how many moles of Cu will I get out of 0.068564 moles of aluminum if I have 3 moles of Cu for every 2 moles of aluminum, right? Copper's all on the top, aluminum's all on the bottom. So that times 3 divided by 2. We're going to get 0.10285 moles. I rounded that. I have the whole number in my calculator. Now we're going to do our last step. How many grams of copper are there in 0.10285 moles? If there are 63.546 grams in 1 mole. So I take that number and times it by 63.546, and I get 6.54 grams. That's to my 3 significant figures, which is what I should have. All right. Now, we can go over here and we can take this number and we can put it into our actuals. 6.535 ... grams. We can figure out our actual. Now we do this by taking this number, multiplying both sides by this. So 0.566 times 6.535 ... equals our actual amount. So we multiply this by our 0.566, and I get 3.70 grams to 3 significant figures. All right, there you have it. That's how you do theoretic percent yield. So your stoichiometry gives you your theoretical yield. Your actual is determined by doing an experiment. And there's your results. All right. I hope you understand what percent yield is, and I hope that you can do it on your own. Thank you for watching.